Hello everyone, welcome back to Maths Marathon classes. Hope your preparation is going on for JEE exams. This time I'll be doing 2024 JEE main complex numbers of January shift. Okay, discuss the questions and also see the number of questions appeared from different concepts of this chapter. January shift. Algebra of complex numbers, no questions are asked. Modulus, conjugate, argument, there are 6 questions. Okay. Polar form, De Moivre's theorem, there are 2 questions. Cube roots of unity, nth roots of unity, also there are 2 questions. Geometrical representation, 3 questions. Miscellaneous, 1 question. Altogether we have 14 questions. Okay. We'll discuss the questions one by one. So a very important chapter, complex numbers. And if you learn all the concepts, easy to score marks. Okay, it's quite interesting also. Look at the first one. Set S is given like this. Z belongs to C mod Z minus 1 equal to 1 and root 2 minus 1 into Z plus Z bar minus I into Z minus Z bar equal to root 2. So Z1 and Z2 are belonging to the set S. We says that mod Z1 is maximum of mod Z and mod Z2 is minimum of mod Z where Z belongs to S. Want to find mod of root 2 Z1 minus Z2 the whole square. So what we'll do is we'll find the equation of this mod Z minus 1 equal to 1 in the Cartesian form. Okay, we must know that mod Z minus Z naught equal to R represents a circle having center at Z naught, radius is R. Okay, and also we'll simplify this. Z plus Z bar is 2 times real part of Z. Z minus Z bar is 2I imaginary part of Z. All those things will simplify and solve the 2 equations and get the 2 values of Z, that is Z1 and Z2. Okay, so the first one is equation of circle. Mod of Z minus 1 equal to 1 represents a circle having center at 1, 0, radius is 1. You must know that mod Z minus Z naught equal to R represents a circle having center at Z naught, radius is R. Mod of Z minus Z naught is equal to R is what? Circle is the equation of circle with center at Z naught, radius is R. Represents circle with center at Z naught and radius R. You must know this. So mod Z minus 1 equal to 1 represents circle with center at 1, 0 and radius 1. Therefore, mod Z minus 1 is equal to 1 is a circle with center at 1. 1 means 1, 0, correct? With center at 1, 0 and radius is 1 unit. So I can write the equation of circle in the Cartesian form. What I am trying to do is I am solving the 2 equations. First equation is the equation of circle and the second one is a straight line. So I am solving the 2 equations, that getting the points of intersection of the circle and the straight line. So I'll write the equation of circle in the Cartesian form. Equation of circle is what? X minus 1 the whole square plus y minus 0 the whole square is equal to 1. X minus h the whole square plus y minus k the whole square equal to r square. This is equation 1. Another equation is given to us. Another equation is given as and what is given? Root 2 minus 1 into z plus z bar. Z plus z bar is 2 times x. If you take z as x plus iy, z plus z bar is 2 times real part of z. Real part of z is x. If you take the complex number z equal to x plus iy, z plus z bar is 2x. Learn this. Properties of conjugate. Z minus z bar is 2iy. Okay. So minus I into z minus z bar is 2iy is equal to 2 root 2. Correct? We can divide the entire equation by 2. I can divide the entire equation by 2, and also I can use the fact that I square is minus 1. Minus I square is plus 1. Correct? So dividing by 2 and writing the equation like this. Root 2 minus 1 into x minus I square. Minus I square is plus 1. I am dividing by 2 and writing plus y is equal to root 2. Equation 2. We will solve the two equations. The first one is equation of circle. Second one is equation of straight line. It takes the form ax plus by equal to c. We will find the points of intersection of these two, circle and straight line. From second equation, we can write y as root 2 minus 1x. Correct? That will substitute in the first equation and get the points of intersection. From the second equation, equation 2 implies y is equal to root 2 minus of root 2 minus 1x. Substitute equation 2 in equation 1. Correct? Put equation 2 in equation 1. What we get? X minus 1 the whole square plus y is here. Y minus 0 the whole square, same as y square. Y square is this. Square this and write. Y is this. Square this and write. Root 2 minus of root 2 minus 1x the whole square is equal to 1. Expand this. Get the values of x. X square plus 1 minus 2x. Correct? Expanding this. Root 2 square is 2 plus root 2 minus 1 the whole square into x square. Root 2 minus 1 the whole square is how much? Root 2 square, 2 plus 1, 3 minus 2 root 2. 3 minus 2 root 2 into x square minus 2ab minus 2 into root 2 minus 1x minus 2 root 2 into root 2 minus 1x minus 1 equal to 0. I can write this as quadratic in x and find the roots of this. I'll get two values of x and I can find the corresponding values of y. So I'll get the points of intersection. Z1 and Z2 will get two complex numbers belonging to the set S. Then I can find out Z1, Z2. Mod Z1 is maximum of mod Z. Mod Z2 is minimum of mod Z. Find out Z1, Z2, satisfy those conditions. Then I can find out. This is not a difficult question, but little time consuming, little lengthy. Okay, I need to simplify this. Correct? Square of root 2 is 2. Root 2 minus 1x the whole square is written here. 2 plus 1, 3 minus 2 root 2 x square minus 2 root 2 into root 2 minus 1x. Plus 1 minus 1 will cancel there. Correct? I can write this as quadratic in x. This will be x square into 3 minus 2 root 2 plus 1, that is 4 minus 2 root 2. Correct? Then I can take x common there. Plus 1 minus 1 will cancel. If you take minus 2x common here, minus 2x is common. What remains is root 2 into root 2 is 2. If you take minus 2x common, what remains here? 1. I took minus 2x common. Root 2 into root 2 is 2. Minus 2. Correct? Minus 2x is taken out. Minus root 2 into minus 1, that is plus root 2. Then plus 2, plus 1 minus 1 cancels, plus 2 remains. Equal to 0. I am getting this as quadratic in x. I can still divide by 2, correct? This entire equation I can divide by 2. Can add one page, there is no space here. So I am dividing by 2 and writing. This is root 2 minus 1 actually, correct? Divide by 2, the entire equation. I'll get x square into 2 minus root 2 x square into 2 minus root 2, correct? X square into 2 minus root 2. This is root 2 minus 1 into x minus of root 2 minus 1x plus 1 minus of root 2 minus 1x, correct? Dividing by 2 and writing minus root 2 minus 1x plus 1 equal to 0. Solve this equation by using the formula method. X is equal to minus b, minus of this, that is root 2 minus 1 minus b plus or minus root of b square minus 4ac minus of root 2 minus 1 the whole square, that is same as root 2 minus 1 the whole square, minus b, correct? Minus b plus or minus root of b square minus 4ac. If you want, I can write 1 minus root 2 the whole square. Both are same. One minus root 2 the whole square, correct? Minus 4ac, 4 into c into a, divided by 2a. So what do you get? This is equal to root 2 minus 1 plus or minus root of 1 minus root 2 whole square is 1 plus 2 minus 2 root 2 minus 8 plus 4 root 2. Correct, no? 2 minus root 2 dividing by 2 and writing. This is 2 root 2 minus 5. Minus b plus or minus root of b square minus 4ac. 1 minus root 2. Is it correct? X square is taken common here. Correct? 3 minus 2 root 2 plus 1. 4 minus 2 root 2. Then x will take common. Minus 2x. 1. Minus 2x is taken out. Minus 2x is taken out here between these two. Correct? I should write plus, I think, here. Correct? Minus 2x is taken out. No? Minus 2x is taken out. 1. And here minus 2x is taken out. Minus 2x taken out means it becomes plus 2 minus root 2. Correct? This is plus 2 minus root 2 here. Root 2 into root 2 is 2. Correct? Minus root 2. So that it becomes 3 minus root 2 inside the bracket. 3 minus root 2 here. 3 minus root 2. What I am getting is 3 minus root 2. Correct? 3 minus root 2 x. Minus 2x is taken out. Minus 2x into 1, minus 2x. Minus 2x into 2. Correct? And minus into minus plus. Minus 2x is taken out. Correct, no? Minus 2x into 2. Minus 4x. Minus into minus plus. Now it's correct. Now we can solve this using the formula method. X equal to minus b. Minus of minus 1 becomes plus. Minus of b plus or minus root of b square. Minus of 3 minus root 2 whole square. That is same as 3 minus root 2 whole square. Or also you can write root 2 minus 3 the whole square. minus 4ac, 4 into c into a, correct, divided by 2a. So what do we get? This is equal to 3 minus root 2 plus or minus root of root 2 square 2, 3 square is 9, minus 6 root 2, minus 8 plus 4 root 2 divided by 2 into 2 minus root 2. This will be how much? 11 minus 8, 3. So I am getting this as 3 minus root 2 plus or minus this is 2 plus 9, 11. 11 minus 8 is 3. Minus 6 root 2 plus 4 root 2 is minus 2 root 2. We can complete the square for that. Divided by 2 into 2 minus root 2. And note that 3 minus 2 root 2 is root 2 minus 1 the whole square. 3 minus 2 root 2 is 3 minus 2 root 2 is what? Root 2 minus 1 the whole square. Correct? So this is equal to what? 3 minus root 2 plus or minus, this is root 2 minus 1 the whole square. Square root of root 2 minus 1 the whole square is root 2 minus 1 divided by 2 times 2 minus root 2. Once you take plus, once you take minus, so that we get two values of x. Okay? From this, x is equal to, if you take the positive value, minus root 2 plus root 2 will cancel. 3 minus 1 becomes 2. Taking the positive value, 3 minus root 2 plus root 2 minus 1 divided by 2 into 2 minus root 2. Minus root 2 plus root 2 will cancel. 3 minus 1 is 2. 2 cancels. We get 1 by 2 minus root 2. Or another value of x is 3 minus root 2, correct, minus of root 2 minus 1 divided by 2 times 2 minus root 2. 3 minus minus 1 is 4. Minus root 2 minus root 2 is minus 2 root 2 divided by 4 minus 2 root 2. Is equal to 1. So I'll get two values of x. X is 1 by 2 minus root 2. Another one is x equal to 1. When x is 1 by 2 minus 2 root 2, find the corresponding value of y. When x is 1 by 2 minus root 2, y is how much? Y is root 2 minus of root 2 minus 1x. Y is root 2 minus of root 2 minus 1x, which is root 2 minus of root 2 minus 1 into x is 1 by 2 minus root 2, that is divided by 2 minus root 2 here. Take common denominator, 2 minus root 2. 2 into root 2, 2 root 2 minus root 2 into root 2 is 2 minus root 2 plus 1. 2 root 2 minus root 2, that is root 2. Root 2 minus 1 by 2 minus root I am getting. Root 2 minus 1 divided by, denominator I can take root 2 common, which will be root 2 minus 1. Root 2 minus 1 cancels, we get 1 by root 2. When x is 1 by 2 minus root 2, y is 1 by root 2. When x equal to other value, we got 1 now. When x is 1, y is how much? Y is equal to root 2 minus of root 2 minus 1 into x, which is root 2 minus of root 2 minus 1 into 1. Correct? Root 2 minus root 2 0, minus of minus 1 plus 1. So when x is 1, y is 1. When x is 1 by 2 minus root 2, y is 1 by root 2. So I am getting the 2 points of intersection of the straight line in the circle. Correct? We had the equation of the straight circle and the straight line. The points of intersection of the circle and the straight line, we are getting like this. And I need to find mod z1 is maximum of mod z. Mod z2 is minimum of mod z, which is having more modulus value find out. If you take this as one complex number, I'll take z1 Z1 as 1 by 2 minus root 2, 1 by 2 minus root 2 plus I into 1 by root 2. And Z2 is 1 plus I into 1. Correct? This has more modulus than this. If you find modulus of this, that is going to be equal to root 2. If you find modulus of this, you can find out if you want. 1 by 2 minus root 2 whole square plus 1 by root 2 square, square root of that I should take. If you find mod of this, that will be root of 1 by 2 minus root 2 the whole square. If you want, you can rationalize this, multiply and divide by the conjugate. If you multiply and divide by 2 plus root 2, that will be 2 plus root 2. I'll simplify one more step here for Z1. Z1 is multiply and divide by 2 plus root 2. So we get 2 plus root 2. 2 minus root 2 into 2 plus root 2. 4 minus 2, that will be 2 plus I into 1 by root 2. Correct? If you simplify this, 2 by 2 will be 1. 1 plus 1 by root 2 it is. Correct? 1 plus 1 by root 2 plus I into 1 by root 2. Definitely this complex number Z1 has more modulus than this, because 1 plus 1 by root is bigger than 1. Correct? And 1 is bigger than 1 by root 2. Still, if you find out modulus, I can add one more page here. It's very lengthy. Mod Z1, if you find out. Z1 we got it as 1 plus 1 by root 2. Correct? Plus I into 1 by root 2. We got Z1 like this. Z1 we got like this. 1 plus 1 by root 2 plus I into 1 by root 2. And Z2 we got 1 plus I. Z2 we got 1 plus I. If you find modulus of this, mod Z1 is equal to root of 1 plus 1 by root 2 the whole square plus 1 by root 2 whole square is equal to root of 1 plus 1 by root 2 square is half. Correct? 2 into 1 into 1 by root 2 by root 2, that is root 2 plus half. Half plus half 1, 1 plus 1 2. So we'll get modulus of Z1 is root of 2 plus root 2. And here mod Z2 is going to be equal to root of 1 plus 1, which is equal to root 2. Definitely root of 2 plus root 2 is bigger than root 2. Correct? So this is maximum and this is minimum. Correct? So we need to find what? We need to find the value of this. Mod of root 2 Z1 minus Z2 whole square. Required is finally mod of root 2 Z1 minus Z2 the whole square. Correct? This is what we need to find. Mod of root 2 Z1 minus Z2 whole square. So Z1 is here. That you have to multiply by root 2 and substitute here. Root 2 into what we have? 1 plus 1 by root 2. Correct? Plus I into 1 by root 2. Plus I into 1 by root 2 multiply by root 2. That will be plus I. Minus Z2. Z2 is 1 plus I. Simplify this. Root 2 into 1, root 2. Plus root 2 into 1 by root 2 is 1. Correct? Plus I minus 1 minus I square. Plus 1 minus 1 add up to 0. Plus I minus I add up to 0. What you get is mod of root 2 square. Mod root 2 is root 2. Root 2 square is 2. The required answer is 2. Quite lengthy question. Have to be very patient to solve this question. Get the points of intersection of the two. One is a circle, another one is a straight line. After getting the points of intersection, maximum of mod Z is mod Z1, minimum of mod Z is mod Z2. Substitute the values of Z1 and Z2 as the complex numbers. Question asked on 1st of February, first shift, JEE Main 2024. Equation of circle and a straight line. Solving the two equations, getting the points of intersection. Solution is shown here in detail. Okay, answer is 2. Move on to the next one. Let Z belongs to the complex number satisfying P and Q. Two sets are given here. In P intersection Q, I need to find the maximum and minimum at Z1, Z2 of this. And the given mod Z1 square plus 2 into mod Z2 square plus alpha plus, this should be equal to, not al, plus, is equal to alpha plus beta root 2. Find alpha plus beta, where alpha and beta are the integers. So mod of Z plus 2 minus 3i less than or equal to 1. What is set P? Find out first. Set P is mod of, I can take minus and common here, minus of 2 plus minus 2 plus 3i, correct? Minus 2 plus 3i. Minus, and if you take common, it becomes minus 2 plus 3i is less than or equal to 1, correct? Minus of minus 2 is plus 2. Minus into plus, minus. So this represents a circle having points on the circle and interior to circle. Center at minus 2, 3, radius is 1. Points on the circle and interior to circle. Points on the circle and interior to circle. Interior to the circle. Having center at minus 2, 3. Correct? Having center at minus 2, 3. Having center at minus 2, 3 and radius is 1. Correct? Because mod of z minus z naught less than or equal to r represents points on the circle and interior to circle. Center at z naught, radius is r. This is z naught. Minus 2 plus 3i is written as a point, minus 2, 3. Radius is 1. Mod of z minus z naught less than or equal to r represents points on the circle and interior to circle, having center at z naught and radius is r. This is radius. 1 is radius. Center is at minus 2 plus 3i, which is written as minus 2, 3. And set q is given like this. Z belongs to complex number. Set q is given as z into 1 plus I, z into 1 plus I plus z bar into 1 minus I, z bar into 1 minus I less than or equal to minus 8. We can use z as x plus iy, the complex number, and simplify it first. And find out the region P intersection Q, region common to both P and Q to find out. Z is x plus iy into 1 plus I. Z bar is x minus iy into 1 minus I less than or equal to minus 8. From this, you take x common. If you take x common, x into 1 plus I, x into 1 minus I, correct? X you take common. What means 1 plus I plus 1 minus I. 1 plus I plus 1 minus I. Here you can take iy common. If you take iy common, what remains is iy into 1 plus I. No, so iy is taken out. 1 plus I. Iy is taken out. So minus of 1 minus I. Less than or equal to minus 8. Plus I minus I will cancel, correct? Add up to 0. 1 plus 1, 2. 2x. 1 minus 1 cancels. I minus minus I plus I is 2i. 2i into iy, that will be 2i square. I square is minus 1, so minus 2i. Correct? This becomes plus 2i. 2i into I is 2i square. 2i square is minus 2. Less than or equal to minus 8. Divide the entire equation by 2 and write x minus y less than or equal to minus 4. From this, I can represent the circle having center at minus 2, 3, radius 1. And this is straight line, x minus y equal to minus 4. We want x minus y less than or equal to minus 4, which is a region. I'll get the region for that. And find the common region. In that common region, I need to find the minimum and maximum values of this expression, which occurs at z1 and z2. At which point the minimum and maximum values occurs, you have to find out. Maximum value occurs at z1, minimum occurs at z2. Find out the points z1 and z2, complex numbers, and substitute here. z1 square. Mod z1 square plus 2 into mod z2 square is equal to alpha plus beta root 2. Find alpha and beta as integers. Then you can find alpha plus beta. Numerical type question asked. Hope it is clear so far. Correct? Mod of z minus z naught less than or equal to r represents the points on the circle and interior to circle having center at z naught, radius is r. So we can represent circle having center at minus 2 comma 3. Minus 2 comma 3 lies in the second quadrant. Radius is 1. And x minus y equal to minus 4 also I can draw. Correct? Straight line. And I want to represent the region that x minus y less than or equal to minus 4. And region common to P and Q to find out. Okay? We shall add one slide here. So that circle has center at minus 2 comma 3. Circle has center at minus 2 comma 3 and radius is 1. Circle has center at minus 2 comma 3, radius is 1. So minus 2 comma 3 somewhere here, second quadrant. Circle has center at minus 2 comma 3. Correct? Circle has center at minus 2 comma 3, radius is 1. And we have this straight line x minus y less than or equal to minus 4. We draw x minus y equal to minus 4. We draw first x minus y, we draw first x minus y equal to minus 4. We can divide by minus 4. We get x by minus 4 plus y by 4 equal to 1. Correct? Because x intercept is minus 4, y intercept is 4. Divide the entire equation by minus 4. X intercept is minus 4 means it passes through the point minus 4 comma 0. Y intercept 4 means it passes through the point 0 comma 4. Minus 4 comma 0, 0 comma 4. Minus 4 comma 0 and 0 comma 4. We are not sure whether the line is outside the circle or touching the circle or intersecting the circle, correct? So we shall find out the points of intersection of these two. And solve the two equations. Put x equal to y minus 4 in this. X is how much? Y minus 4. That will substitute in the equation of circle. Circle equation we can write. If you know the center as h comma k and radius as r, we can write the equation of circle. Center is minus 2 comma 3. No. Equation of circle is what? X minus 2 the whole square plus y minus 3 the whole square. Correct? Equation of circle I can write in the Cartesian form. Center is h comma k, radius r means equation of circle is x minus h the whole square plus y minus k the whole square equal to r square. Radius is 1 square. Solve these two equations. Put x equal to y minus 4. Put x equal to y minus 4 in the equation of circle. What we get? When you put x equal to y minus 4, put x as y minus 4. Y minus 4 plus 2. That will be y minus 2. Y minus 2 the whole square plus y minus 3 the whole square is equal to 1. Correct? You can solve this. You can get this as quadratic in y. Y square plus 4 minus 4y plus y square plus 9 minus 6y minus 1 equal to 0. You can simplify it and write this as quadratic in y. 2y square minus 10y, 13 minus 1, 12. Correct? I am getting this as quadratic in y. 2y square minus 10y. Correct? 2y square minus 10y plus 12 equal to 0. We can divide the entire equation by 2. Y square minus 5y plus 6 equal to 0. We can factorize this as y minus 2 into y minus 3 equal to 0. Y minus 2 into y minus 3 equal to 0, which gives y is equal to 2 or y is equal to 3. When y is equal to 2, we can find out x equal to how much? When y is equal to 2, x is equal to how much? X is y minus 4. X is y minus 4. So 2 minus 4, which is minus 2. And when y is equal to 3, x is y minus 4, which is 3 minus 4, which is equal to minus 1. So points of intersection are minus 2 comma 2 and minus 1 comma 3 points of intersection I'm getting. That means that line is going to intersect the circle. The line x minus y equal to minus 4, correct? X minus y equal to minus 4 is going to intersect the circle at two distinct points, something like this. X minus y equal to minus 4. This point is minus 4 comma 0. This point is 0 comma 4, correct? And intersection point is one is at minus 2 comma 2 and minus 1 comma 3. This is minus 1 comma 3. And another point is minus 2 comma 2. This point minus 2 comma 2. The points of intersection is P and Q, I'll call. P and Q are the points of intersection of the line with the circle. And they asked to determine the region, no, x minus y less than or equal to minus 4 you want to shade this region. And the first set is points inside the circle, on the circle and inside the circle. The second one is what? X minus y less than or equal to minus 4. To shade x minus y less than or equal to minus 4, you can take a convenient point, say 0 comma 0. X minus y less than or equal to minus 4. You can take 0 comma 0. Does it satisfy? 0 comma 0. 0 minus 0. 0 is less than or equal to minus 4. 0 less than or equal to minus 4 is false. Inequality is false because 0 is greater than minus 4, correct? So inequality is false means the graph will not come towards the origin. It goes outside, away from origin. If the inequality is true, the graph or the region is towards the point which you considered. Now the inequality is false, but you know 0 comma 0 lies in the lower half of this line. 0 comma 0 is there. It is the lower half, correct? Inequality is false. So it goes away from the point 0 comma 0. So the upper half it is, because inequality is false. So my region is going to be inside the circle, points on the circle and inside the circle and above the line, correct? So my common region is going to be this. This is going to be the common region. Okay, common region is this. They asked to find P intersection Q. If you want, you can name these points as A and B if you want. Don't take P and Q, that is given as sets there, correct? You can name these points as A and B, points of intersection. Points of intersection are A and B. A and B are the points of intersection. Of course, AB is a chord. Now, in this region, common region to the circle and the region determined by the line, okay, we want to find at which point the maximum occurs. In the P intersection Q, mod of z minus 3 plus 2i be maximum at z1, minimum at z2. Mod of z minus 3 plus 2i. You can write mod of z minus 3 plus 2i as z minus of 3 minus 2i. That means 3 comma minus 2. The point is mod of z minus 3 plus 2i. See, mod of z minus 3 plus 2i, okay, could be written as mod of z minus of 3 minus 2i, correct? Minus of. So point is 3 comma minus 2. 3 comma minus 2 lies in the second quadrant only. 3 comma minus 2 somewhere, okay? Sorry, it lies in the fourth quadrant. 3 comma minus 2 lies in the fourth quadrant. X is positive, y is negative, somewhere here. 3 comma minus 2, somewhere here. 3 comma minus 2 lies in the fourth quadrant. So from this point, I need to find the minimum and maximum values to this region. Where it occurs minimum and where it is maximum, I have to find out. If you go along the diameter, at this point the minimum value occurs. And at this point the maximum value occurs. 3 comma minus 2 lies in the fourth quadrant, correct? So now if you join this, this is going to be the minimum value. This is minimum. From here to here, this is going to be minimum. And it is going to be the midpoint of this chord AB here. Because I am taking the minimum or maximum along the diameter of the circle, always normal. Because for a circle, the diameter is a normal. Minimum value or the maximum value, I am taking along the diameter. So diameter is a normal to the circle. Normal means it is perpendicular to tangent. So this is diameter, along the diameter I'm taking. So center of the circle is here. What is center of the circle? Minus 2, 3. And we know the perpendicular drawn from the center to the chord is going to bisect the chord. So minimum value occurs at this point. That is, according to the question, minimum value occurs at Z2. Maximum value occurs at Z1. Correct? So maximum value is here. Maximum value occurs at this point, Z1. And minimum value occurs at the point Z2. Z2, that is. At this point, the minimum value occurs. At this point, minimum value, and at that point, maximum value. So, what is this point if you want to find out? Z2, that is going to be the midpoint of AB, because the perpendicular drawn from the center to the chord is going to bisect the chord. We have the theorem. So, Z2 is going to be the midpoint of AB. Z2 is the point where the minimum value occurs, minimum distance of this point to this region, that is at the point Z2. Z2 happens to be the midpoint of the chord AB. Z2 is the midpoint of AB. Midpoint of AB. So Z2 is what? Apply midpoint formula, x1 plus x2 by 2, y1 plus y2 by 2. x1 plus x2 by 2, y1 plus y2 by 2. Is equal to how much? Minus 3 by 2, comma 5 by 2. That is the minimum value. And the maximum value occurs at Z1. To find Z1, I am using the parametric form of the equation of a straight line. So what I am doing is, I am using the parametric form of the equation of straight line, which is given by x minus x1 by cos theta equal to y minus y1 by sin theta equal to plus or minus r. So to find Z1, what I am using is the parametric form of the equation of straight line. The parametric form of the equation of the straight line. It's also called as a symmetric form of a straight line. X minus x1 by cos theta equal to, is given by this. X minus x1 divided by cos theta is equal to y minus y1 divided by sin theta is equal to plus or minus r. This is a parametric form of a straight line. It's also called as symmetric form of a straight line. Okay. So what I'm going to do is to find the point Z1 as a complex number. I'm shifting the center of the circle by a distance of how much? What is the radius of the circle? Radius of the circle is 1, correct? So I'm shifting this point minus 2, 3 by distance 1 unit. By distance 1 unit. Okay. To find Z1. And also you need to find along which line you are shifting that point. I'm shifting the center minus 2, 3 by distance 1 unit to get Z1. Because at Z1, the distance between this point and that region is going to become maximum. The distance between the point 3, minus 2. They asked to find in P intersection Q where the minimum value of this occurs and where the maximum value of this expression occurs. Mod of Z minus 3 plus 2i, written as mod of Z minus of 3 minus 2i. Taken minus and com because I want to compare with mod of Z minus Z1. Remember, mod of Z minus Z1 represents distance between Z and Z1. So mod represents the distance between the 2 points by distance formula. Okay. So distance between these two should become minimum and maximum where you are finding out. So distance between these 2 points will be minimum at Z2, maximum at Z1. So Z2 already I got the midpoint of AB because the perpendicular drawn from the center to the chord is going to bisect the chord, means it becomes a midpoint of AB. So using midpoint formula, I got the Z2 as a complex number. Now I am finding Z1. To find Z1, I am shifting this point minus 2, 3 by distance 1 unit because radius is 1. Correct? Distance between the point minus 2, 3 and Z1 is 1, which happens to be the radius of the circle. So radius is 1. I am shifting it by distance 1 unit. So R is 1. Which point I am shifting? That is x1, y1. Along which line you are shifting, that line slope we should know. I know the point center minus 2, 3 and 3, minus 2. we can find the slope of line joining these 2 points. Slope of line joining minus 2 comma 3 and 3 comma minus 2 if find out. Slope of line joining minus 2 comma 3, slope of line joining minus 2 comma 3 and 3 comma minus 2 is how much? Slope is m is equal to y2 minus y1 divided by x2 minus x1. Correct? This point is x1 y1, x2 y2. Slope is y2 minus y1 by x2 minus x1. Subtract the y coordinates minus 2 minus 3 divided by 3 minus minus 2. So this becomes minus 5 divided by 5, which is equal to minus 1. Slope is minus 1. Slope is tan theta. Correct? Tan theta is minus 1. So theta is equal to 3 pi by 4. I am shifting the point minus 2 comma 3 by distance 1 unit to get the point z1. Correct? My aim is to find z1. Shifting the point minus 2 comma 3 by distance 1 unit. Correct? Along which line? Along this line. Slope of that line is minus 1. Slope is tan theta. That means that line is making inclination of 135 degree or 3 pi by 4. Correct? 3 pi by 4 with x-axis. Positive x-axis. So using that symmetric form, I am shifting this point, no? Minus 2 comma 3. So x minus x1 divided by cos 3 pi by 4 is equal to y minus y1 divided by sin 3 pi by 4 is equal to plus or minus 1. Hope you understand. Which point I am shifting? I am shifting this point, minus 2 comma 3. That is your x1, y1. x1 is minus 2, y1 is 3. I am shifting the point minus 2 comma 3. Correct? So x1 is minus 2, y1 is 3. Theta I got 3 pi by 4. Correct? Theta is 3 pi by 4. Substituting cos 3 pi by 4, sin 3 pi by 4. And the distance by which I am shifting it is 1 unit because radius of the circle is 1. Correct? So plus or minus 1 using this. Now find out x and y from this. We know cos 3 pi by 4 is minus 1 by root 2. This is x plus 2 divided by cos 3 pi by 4 is minus 1 by root 2. Sin 3 pi by 4 is 1 by root 2. Once you take 1, another case is minus 1. X plus 2 divided by minus 1 by root 2 is equal to y minus 3 divided by 1 by root 2 is equal to minus 1. So cross multiply and rearrange. So you get x is equal to how much? Minus 1 by root 2 minus 2. Minus 1 by root 2 minus 2. Y is how much from this? 1 by root 2 plus 3. From this x is how much? Minus 1 by root 2 minus 2. Y is minus 1 by root 2 plus 3. Correct? Beginning with this. So I should take a point which is x is, there is a point here. The point should lie in the second quadrant, right? Point is here. Minus 2 comma 3, that side it is. So I can tell which point is going to satisfy you. I'll take this point, minus 1 by root 2 minus 2, because here y is more than 3. Here y is less than 3, correct? By looking at the figure, my figure is almost rough, but still I can tell that y value will be x is minus 2, x is less than minus 2 and y is greater than 3, correct? So I'll take this point. I'll take this point. So that point is z1 where the maximum distance occurs. So z1 is minus 1 by root 2 minus 2, writing it as a complex number, plus I into 1 by root 2 plus 3. This is your z1. And z2 already we got. z2 is here, minus 3 by 2 plus I into 5 by 2. z2 is minus 3 by 2 plus I into 5 by 2. we need to find what? We need to find mod z1 square plus 2 into mod z2 square, that is equal to alpha plus beta root 2. Mod z1 square plus 2 times mod z2 square, we need to find out. Mod z1 square is how much? Mod z1 square. Mod z1 square plus 2 times mod z2 square. Square of this. Mod z1 square is, mod z1 is root of. Mod z1 square is without root. Just take the squares of this. Minus 1 by root 2 minus 2 the whole square. That is same as 1 by root 2 plus 2 the whole square. And this is 1 by root 2 plus 3 the whole square. What do you get? This is equal to 1 by 2 plus 4, correct? Plus 2ab, 2 into 2, 4 by root 2, which is 2 root 2. This is 1 by 2 plus 3 square 9 plus 6 by root 2, which is 3 root 2. Simplify this. Half plus half is 1. 1 plus 9, 10. 10 plus 4, 14. 14 plus 5 root 2. 14 plus 5 root 2. And mod z2 square. From this I can write mod z2 square is equal to minus 3 by 2 square, 9 by 4 plus 25 by 4. Correct? Which is equal to 34 by 4. 34 divided by 4, which is 17 by 2. Finally, I need to find what? Therefore, mod z1 square plus 2 times mod z2 square. Mod z1 square we have 14 plus 5 root 2 plus 2 times mod z2 square. Mod z2 square is 17 by 2. 2 times that is 17. 17 plus 14 is 31. 31 plus 5 root 2. Compare with alpha plus beta root 2. So what we get is alpha is equal to 31 and beta is equal to 5. Therefore, alpha plus beta we need to find. Alpha plus beta is 36. Required answer is 36. Quite lengthy one. Okay. 3 to 4 minutes is required if you do it fast also. Had to be fast, quick, correct? Therefore, finally I can conclude that my alpha plus beta is equal to 31 plus 5 is equal to 36. Hope it's clear. Using the parametric form of the equation of line, I am getting the answer. Maximum value occurs at Z1 and minimum value occurs at Z2. Once again I explain. First you represent the set P, mod of Z minus Z0 less than or equal to a circle with points on the circle and interior to circle. Center at Z0, radius is R. Right? 2 minus 3 has minus of minus 2 plus 3i. Correct? Center is minus 2 comma 3, which lies in second quadrant. Radius is 1. The first point, first set is over. Set Q. To simplify set Q, take Z as x plus iy. So Z bar is x minus iy. Go on, simplify. Use the fact that I square is minus 1 and simplify. Get like this. X minus y less than or equal to 4. X minus y equal to minus 4 is written like this in the intercept form. X intercept minus 4 means passes through the point minus 4 comma 0. Y intercept 4 means passes through 0 comma 4. Draw the line. Okay. And also get the points of intersection of the circle and the straight line. Circle is written like this in the Cartesian form. Center is h comma k, radius r, means equation of circle is x minus h the whole square plus y minus k the whole square equal to r square. If you know the center and radius, we can write the equation of circle. X minus h the whole square plus y minus k the whole square equal to r square. Center is h comma k, radius r. Solve the two equations to get the point of intersection of the circle and the straight line. So that is shown here. Points of intersection of the circle and the straight line. They intersect at A and B. A is minus 2 comma 2, B is minus 1 comma 3. Points of intersection we got. One is x equal to minus 2, y equal to 2, and x equal to minus 1, y equal to 3. Points of intersection are A and B of the circle and the straight line. And the region x minus y less than or equal to minus 4 is in the upper half of the line x minus y equal to minus 4. This line is x minus y equal to minus 4. x minus y less than or equal to minus 4 if you want to determine whether it is upper half or lower half of the line. 0, 0 is a convenient point. 0 minus 0 is 0. 0 less than or equal to minus 4 is false. In fact, 0 is greater than minus 4. Inequality is false. So graph is not towards 0, 0. 0, 0 lies in the lower half. Inequality is false. So graph is the other way, the upper half, above the line. Okay. So 0, 0 does not satisfy. So region is away from 0, 0. That means it is above the line, not towards the origin, away from the origin. So going up. So upper half of the line and inside the circle is shaded part. That is common region. This region is P intersection Q. In that region, we need to find the minimum and maximum where it occurs from the point 3, minus 2. Want to find minimum and maximum values of this expression occurs at which point in that common region. Okay. So mod of z minus 3 plus 2i, that is what they ask. To find in P intersection Q, in P intersection Q is this. In this shaded region, in that shaded region, what we need to find is this expression mod of z minus 3 plus 2i where maximum value occurs, that is at z1, where minimum occurs of this expression. Mod of z minus z1 is represents distance between z and z1. You must know that. So distance between z means the point in the region P intersection Q. Take any point in the region P intersection Q. Take any point in the region P intersection Q, that is z. And minus 3 plus 2 is minus of 3 minus 2i. 3 minus 2, the point is 3 minus 2 lies in third quadrant. From that point to this region, shaded region, where the minimum value occurs, that is at z2. Where the maximum value occurs, that is at z1 according to the question. So z1 happens to be here, z2 happens to be here. z2 happens to be the midpoint of the chord, and the perpendicular drawn from the center to the chord is going to bisect the chord. So I am taking midpoint of AB. To get z2, I am taking midpoint of AB, x1 plus x2 by 2, y1 plus y2 by 2. To find z1, I am shifting this point center minus 2, 3 by distance 1 unit. To find the point z1, I am using the parametric form of the equation of line. This is given this x minus x1 by cos theta equal to y minus y1 by sin theta equal to plus or minus r. R is the distance by which you are shifting. I am shifting by a distance of 1 unit. And x1 is the point minus 2, 3. y1 is 3. Which point you are shifting? Minus 2, 3. That is your x1, y1. Point which you are going to get, that is x, y. Along which line you are shifting? Along this line. Slope of that line matters. Inclination matters. So slope of line joining 3, minus 2 and minus 2, 3 find out. Slope is y2 minus y1 by x2 minus x1. Slope you calculate. Slope you calculate. Okay. Slope of line joining these 2 points. 3, minus 2 and minus 2, 3. Along this line you are shifting it by a distance of 1 unit. Correct? Point which you are shifting is x1, y1. Point which is obtained finally, that is x, y. Along which line I am shifting? Along this line. Slope of that line you find out. Slope of line joining 3, minus 2 and minus 2, 3. Slope is y2 minus y1 by x2 minus x1. Find out. Slope we got minus 1. Slope is tan theta. So theta is 3 pi by 4. That theta is substitute. Cos theta sin theta. Correct? X minus x1 by cos theta. Theta is 3 pi by 4. R is 1. Plus or minus 1. Equate the first and last. Second and last. Get the 2 possibilities. I'll take this according to the figure. This is my point. Required point. That is the complex number. X plus iy. X plus iy. And another value is this. This is rejected. This is rejected. Z2 is the minimum value. Okay. Minimum value occurs at Z2. That already we got here. Z2 is here. Minus 3 by 2 plus I into 5 by 2. Minus 3 by 2 plus I into 5 by 2. Z1 is here. Mod Z1 square you find out. That comes how much? 14 plus 5 by 2. Mod Z2 square is 17 by 2. Finally find mod Z1 square plus 2 into mod Z2 square. We get 31 plus 5 root 2. Compare with alpha plus beta root 2. So alpha is 31, beta is 5. So alpha plus beta is 36. Expanding this. A minus b, a plus b whole square. Minus a minus b whole square. Same as a plus b whole square. 1 by root 2 square plus 2 square plus 2 into 2, 4. 4 into 1 by root 2. 4 by root 2 is 2 root 2. 1 by root 2 square. 3 square. 3 into 2, 6. 6 by root 2 is 3 root 2. 3 root 2 plus 2 root 2 is 5 root 2. Half plus half 1. 1 plus 4, 5. 5 plus 9, 14. 14 plus 5 root 2. So alpha plus beta is 36. Numerical type question. Please make a note of this. Very lengthy, takes time, 3 to 4 minutes time is required to answer this question, even though if you do it fast. With the explanation, still it takes more time. Move on to the next one. Z is a complex number such that mod Z greater than or equal to 1, minimum value of mod of Z plus half into 3 plus 4i is found out. Actually, there is a mistake in the question actually, but I have changed the options and given here. In the question paper, in the original question paper, no options were found for this question. Okay, the right answer. Anyway, I have changed the options and given, and also I'll correct the question and tell what should have been asked. Okay, mod Z greater than or equal to 1 means what? It is a circle having center at origin, radius is 1, and the points on the circle and outside the circle. Mod Z greater than or equal to 1 represents mod Z greater than or equal to 1 represents circle having center at origin, radius is 1, okay, and the points are outside the circle, on the circle and outside the circle, like this, on the circle and outside the circle. Mod Z greater than or equal to 1. Minimum value of this set to find out. That means minimum distance between this point is Z. So mod of, they has to find mod of Z plus half, I multiply inside, 3 by 2 plus 4 by 2 is 2, correct? This is what you have to find out. This is equal to mod of Z minus 3 by 2 minus 2i, correct? Minus of minus. So want to find the minimum distance between the point Z and this point, minus 3 by 2 comma minus 2. Minus 3 by 2 comma minus 2 lies in the third quadrant, some area. Minus 3 by 2 comma minus 2, the point in third quadrant, correct? In third quadrant. And your region is this, coming outside the circle, correct? Want to find the minimum distance between the point in this region and this point, which happens to be 0, correct? It's coming outwards, outside the circle. Mod Z greater than or equal to 1 is circle having center at origin and radius is 1, and the points are on the circle and outside the circle. It's coming out like this. Want to find the minimum distance or minimum value between which point? This point and the point which is coming, a region which is coming out, which happens to be 0. Distance between that point and there only, correct? Minimum distance, minimum value occurs where? If you take this point and itself, distance between the point and itself is going to be 0. That is a minimum distance because the region is coming outwards, correct? So minimum value is 0. Actually, in the original question paper, 0 was not found in the options. I have changed the options and given so that you get the right answer. Okay, at least one correct answer is there among the options. Actually, the question should have been mod Z less than or equal to 1. This inequality should have a reverse. In that case, I'll get points inside the circle. Points inside the circle and on the circle. If they ask mod Z less than or equal to 1. Correct? On and interior to circle. On and interior to the circle. On and interior to the circle. Okay? On and interior to circle. If the question was mod Z less than or equal to 1. In that case, I can find out the minimum value. Minimum value is going to be this in that case, along the diameter. Find out distance between 0, 0 and this point and subtract the radius. If the question was mod Z less than or equal to 1, then the minimum value of this expression is going to be how much? This is called point P. Minimum distance is going to be OP minus radius. In that case, minimum value is going to be equal to how much? OP minus radius. OP is how much? OP is distance formula. Distance between the point 0, 0 and minus 3 by 2, minus 2. How much is that? Root of, I'll get 0 minus 3 by 2. That is 3 by 2 square, 9 by 4. 0 minus 2 whole square, that is 2 square, 4. I'll get OP as root of, correct, 9 by 4 plus 4 minus radius is how much? 1, correct? Radius of the circle is 1. So this will be how much? Root of 4 LCM, 9 plus 16, 25 by 4. 25 by 4 minus 1. That will be 5 by 2 minus 1. In that case, answer would have been 3 by 2. Even that 3 by 2 is also not there. 3 by 2 is the answer in that case. Okay. So if they ask the minimum value of this expression, in the case mod Z less than or equal to 1, then find out the minimum distance. This is going to be the minimum distance. which is got from OP minus radius. OP is distance between the point 0, 0 and minus 3 by 2, minus 2. 0 minus minus 3 by 2 square, that is 9 by 4. 0 minus minus 2 whole square, 4. 9 by 4 plus 4, that is 25 by 4, correct? 4 4s are 16, 16 plus 9, 25 by 4. Root of that is 5 by 2. 5 by 2 minus 1 is 3 by 2. The minimum value is going to be when the question is mod z less than or equal to 1. So geometrical representation type of question. Even question number 3 as well as question number 2. Both are based on geometrical approach. Even fourth one also, the question based on geometrical interpretation only. Given mod of z minus I equal to mod of z plus I equal to mod z minus 1. Given what? According to the question, given mod of z minus I is equal to mod of z plus I is equal to mod of z minus 1. Mod of z minus I means what? It represents distance between the point z and I. I means I can write 1 plus I mean 0 plus I. 0 plus I means the point is 0, 1. I is 1 I. 1 I means 0 plus 1 I. Correct? This point is I means it is 0 plus 1 into I, which is represented by the point 0, 1. Here mod of z plus I means z minus minus I. So z minus minus I means it is 0 minus 1 into I, which is the point 0, minus 1. Here z minus 1 means mod of z minus 1, distance between the point z and 1, 0. 1, 0 is 1 plus I into 0. Correct? 1, 0. So if you plot these points, 0, 1 lies on y-axis. 0, 1 is 0. 1, 0, it is on x-axis. And 0, minus 1 is on the negative y-axis. So which is the point? I can form a triangle using these 3 points. Correct? I can form a triangle using these 3 points. Clearly, O is the point, the origin is equidistant from all these 3 points, which happens to be the circumcenter of this triangle. Circumcenter of this triangle. Okay? O is the only point which is equidistant from the points A, B and C. OA equal to OB equal to OC. Correct? Because Z is the point such that distance between Z and I should be same as distance between Z and minus I, same as distance between Z and 1. 1 means 1, 0. Mod of Z minus Z1 means what? Mod of Z minus Z1 means distance between the points Z and Z1. Means the distance between the points Z and Z1. Distance between the points Z and Z1. Mod of Z minus Z1 means what? It represents the distance between the points Z and Z1. So mod of Z minus I means what? Distance between the point Z and 0, 1. Which is the point which is equidistant from 0, 1, 1, 0 and 0, minus 1. That is 0, 0. If you find out OA, it is 1. Find OB, it is 1. OC is equal to 1. Who happens to be the circumcenter of this triangle ABC. Correct? That means only one point is going to satisfy this condition. Mod Z minus I equal to mod Z plus I equal to mod Z minus 1 is satisfied for only Z equal to 0. Only Z equal to 0. 0 means 0 plus I equal to 0 satisfies this. Correct? Distance between 0, 0 and 0, 1 is 1 unit. Distance between 0, 0 and 1, 0 also 1 unit. Distance between 0, 0 and 0, minus 1 is 1 unit. Correct? Equidistant. The origin is equidistant from the points A, B, C, which happens to be the circumcenter of this triangle. So only one solution. N of S is only one. Question asked on 27th of January, first shift, JEE Main 2024. This question was also asked many years back, maybe in 2010 or somewhere in AI triple exam, the same question was asked. Okay, so please make a note of this. The geometrical representation type of question. Okay, so the point origin which is equidistant from all the 3 points. So number of solutions, the S is having only one element, which is 0 plus I into 0. Only one complex number, 0 plus I into 0 satisfies that equation. That means the point Z is equidistant from the 3 points. Which point Z is equidistant from the points I means 0, 1. Z minus minus I. So that is 0, minus 1. Z minus means 1, 0. 1 means 1 plus I into 0. I means 0 plus 1 into I. Minus I. Z minus minus I. That means point is 0, minus 1. Please make a note how to represent the point in terms of complex number. Complex number in terms of point. And also mod of Z minus Z1. Okay. Learn this geometrical meaning or geometrical representation of a complex number. Move on to the next one. Question number 5. Alpha satisfies the equation x square plus x plus 1 equal to 0. 1 plus alpha power 7 is given to this. A plus b alpha plus c alpha square. A, b, c greater than or equal to 0. Want to find this. You must know that the roots of the equation x square plus x plus 1 equal to 0 are omega and omega square. The roots of the equation. The roots of the equation x square plus x plus 1 equal to 0. Roots of this equation are omega and omega square. Omega is minus 1 plus I root 3 by 2. Omega square is the conjugate. Omega and omega square are conjugates. They are the roots of this equation x square plus x plus 1 equal to 0. And they are also reciprocals. All these things you must know the properties connected to cube roots of unity. Omega is minus 1 plus I root 3 by 2. Minus 1 plus I root 3 divided by 2. And the value of omega square you must know. Omega square is minus 1 minus I root 3 whole thing is divided by 2. Note that omega and omega square are conjugates. They are not only conjugates, they are also reciprocals. 1 by omega is omega square. 1 by omega square is omega. And also it satisfies properties like 1 plus omega square 0. There are properties of cube roots of unity. 1 plus omega square is equal to 0. Omega power multiples of 3 is 1. For all n belongs to Z. All these things you must know. The properties of omega we call. Omega and omega square are conjugates. Omega and omega square are reciprocals. Omega and omega square are the roots of this equation. X square plus x plus 1 equal to 0. 1 plus omega square 0. Omega power multiples of 3 is 1 for all n belongs to Z. So alpha satisfies this. Means you take alpha equal to omega. You can take alpha equal to omega or omega square as you wish. Anyone. I'll take alpha. Alpha satisfies this. Which are the roots of this equation? Omega and omega square. Means omega is going to satisfy this. Even omega square is going to satisfy this. Alpha satisfies this. So take alpha equal to omega. Take alpha as omega. And I want to solve this equation. 1 plus alpha power 7. Given 1 plus alpha to the power 7. 1 plus alpha to the power 7. That is equal to 1 plus omega. Alpha taken omega. Correct? Alpha is taken as omega. If you want, you can take omega square. You will get the same answer. What happens for omega? Same thing happens for omega square most of the time. So, I have taken alpha as omega and use this. 1 plus omega square 0. So, 1 plus omega will be minus omega square from this. So, 1 plus omega is minus omega square whole to the power 7. Minus to the power odd number is minus. Omega square power 7 becomes omega power 14. Which is equal to minus omega power 12 into omega square. And omega power 12 is 1 because 12 is a multiple of 3. Omega power multiples of 3 is 1. Omega power 12 is 1. 1 into omega square becomes minus omega square because omega power 12 is 1. Omega power 12 is 1. Minus omega square is 1 from this. From this, 1 plus omega is equal to minus omega square. So what is minus omega square? 1 plus omega, correct? Minus omega square is nothing but 1 plus omega. That you compare with this. What is omega? Substitute back. Omega is alpha. So this becomes 1 plus alpha. Because omega is nothing but alpha using this back. So now we compare with a plus b alpha plus c alpha square. Comparing with a plus b alpha plus c alpha square. What we get? If we compare, a is equal to 1. A is equal to 1. B is equal to 1. Correct? C is equal to 0. Correct? Compare. A is 1, B is 1 and C is 0. Want to find this. A plus B alpha plus C alpha square. You can compare here itself otherwise. Okay. I got A is 1, B is 1. Want to find 5 times required is what? 5 times 3A minus 2B minus C. Otherwise, I can compare at this stage only. Minus omega square we got, no? Can substitute back. Omega is alpha, so minus alpha square can compare there also. So, find the value of this. 5 into A is 1. So, 3 into 1. 3 into 1 minus 2 into 1 minus C is 0. So, what do you get? 5 into 3 into 1, 3. 3 minus 2 is 1. So, 5 into 1 which is equal to 5. If you are comparing at this stage only, I'll get C as minus 1. A and B will be 0. C is minus 1. Minus of minus plus 1. 1 into 5, 5. In both the cases, I can get the answer as 5 itself. If you want, you can take alpha equal to omega square and work out. What I'm telling you is, no need to substitute this back. Directly at this stage, I can compare with A plus B alpha plus C alpha square. And this is nothing but minus alpha square. Because omega is alpha. If we compare, no, A is 0, B is 0 and C is minus 1. A is 0, B is 0, C is minus 1. Minus of minus 1 plus 1. 1 into 5 is 5. You get the same answer. Even if you compare at this stage also, you get the same answer. Or else you can use minus omega square as 1 plus omega and compare. Omega is alpha, substitute back and compare. A is 1, B is 1, C is 0. Substitute the values of A, B, C, get the answer. Numerical type question answer on 27th of January, first shift, JEE in 2024. Move on to the next question. Same type of question were asked in the PYQs, okay, in the earlier years. Next one. The complex numbers alpha and 1 by alpha bar lie on the circles mod z minus z naught square equal to 4 and mod z minus z naught square equal to 16 respectively. And z naught is given as 1 plus I. Want to find the value of 100 times mod alpha square equal to how much? So numerical type question asked. So first we'll expand this. You must know the formula mod of z1 minus z2 square. I'll write the formula. Mod of z1 minus z2 square is equal to, by properties of modulus we know this, mod z1 square plus mod z2 square minus 2 times real part of z1 into z2 bar. You must know this formula. I'll be using this. Mod z minus z naught square equal to 4. Expand that using this formula. And z naught is given to us 1 plus I. Mod z naught will be root 2. Correct? Z naught given mod z naught is 1 plus I. Z naught is 1 plus I. So mod z naught will be, mod z naught is root of, mod z naught is root of 1 square plus 1 square. Correct? Which is root 2. Mod z naught is root 2. Mod z naught square is 2. Mod z naught is root 2. Mod z naught square will be 2. I'll be using that. Consider the first equation now. Given mod z minus z naught square equal to 4. Given mod z minus z naught square is equal to 4. Expanding this using this formula. What I get? Mod z square from this mod z square plus mod z naught square minus 2 times real part of z into z naught bar, which is equal to 4. Z is how much? They told the complex number alpha is going to satisfy this. Alpha lies on the first circle. 1 by alpha bar lies on the second circle, second equation. First equation is satisfied for alpha. So in place of z, you can put alpha. Put z equal to alpha. This becomes mod alpha square plus mod z naught is root 2. So mod z naught square will be 2 minus, and real of z is z plus z bar by 2. You must know this formula. Real part of a complex number z is z plus z bar divided by 2. Real part of z is z plus z bar by 2. So real part of, otherwise 2 times real of z is z plus z bar. From this I can write 2 times real part of z is nothing but z plus z bar. So 2 times real part of z into z naught bar is what we have? Z into z naught bar, write the complex number, plus its conjugate, plus conjugate of this. What is conjugate of z into z naught bar? That will be z bar into z naught bar bar, that becomes z naught, is equal to 4. And you can substitute, in place of z you can put alpha, because alpha is going to satisfy the first equation. In place of z you put alpha. So what I am going to get is mod alpha square plus 2 minus, in place of z you put alpha, alpha into z naught bar plus alpha bar into z naught is equal to 4. So from this I can rearrange the terms and write 2 minus 4 is minus 2, correct? So I am getting mod alpha square minus 2 is equal to alpha into z naught bar plus alpha bar into z naught. This is equation 1. And another equation is given here, and given mod of z minus z naught square is equal to 16. Expanding this, what do you get? Mod z square plus mod z naught square minus 2 times real part of z into z naught bar is equal to 16, which is the complex number satisfying the second equation. 1 by alpha bar lie on this. That means in place of z you put 1 by alpha bar. In place of z you put 1 by alpha bar. So mod of, it is 1 by mod alpha bar d square, correct? In place of z I am putting 1 by alpha bar, square is there. And mod z naught is root 2, root 2 square is 2, and 2 times real of z is z plus z bar. So this part is going to be equal to, write the same complex number plus its conjugate. Write the same complex number z into z naught bar plus conjugate of that, that will be z bar into z naught bar bar, that is equal to 16. Now you put z as 1 by alpha bar. So this is 1 by mod alpha bar square is same as mod alpha square, correct? Plus 2 minus of, in place of z you put 1 by alpha bar into z naught bar plus z bar, that is z is 1 by alpha bar, z bar will be 1 by alpha into z naught is equal to 16. Simplify this. We'll multiply the entire equation by mod alpha square. Before that, to take LCM and simplify. 1 by mod alpha square plus 2. Here you take LCM. Alpha into alpha bar. Correct? Taking common denominator. That will be what? Numerator becomes z naught bar into alpha plus z naught into alpha bar is equal to 16. Correct? Alpha into alpha bar is nothing but mod alpha square. This part is nothing but mod alpha square. So multiply the entire equation by mod alpha square. What we get? If you multiply the entire equation by mod alpha square, this will be 1 plus 2 times mod alpha square minus z naught bar into alpha plus z naught into alpha bar is equal to 16 into mod alpha square. Alpha into alpha bar is mod alpha square. So from this, you can find out what is alpha into z naught bar plus z naught into alpha bar. Z naught bar into alpha plus z naught into alpha bar is equal to, this is taken that side, correct? This will bring this side, 1 minus 14 alpha square I get. 1 minus 14 into mod alpha square. This we call equation 2. From equations 1 and 2, see, alpha into z naught bar plus alpha bar z naught, same thing, no? Alpha into z naught bar plus z naught into alpha bar. So from equations 1 and 2, I can conclude that these two should be same. Mod alpha square minus 2 equal to 1 minus 14 times mod alpha square. So from equations 1 and 2, I can conclude that from 1 and 2, from equations 1 and 2, I'll write here itself, from equations 1 and 2, what I am getting is mod alpha squared minus 2, mod alpha squared minus 2 is equal to 1 minus 14 times mod alpha squared. 1 minus 14 times mod alpha square. So from this, mod alpha square plus 14 mod alpha square, that is 15 into mod alpha square is equal to 2 plus 1, 3. So mod alpha square is equal to 1 by 5 I am getting. So what I am getting is required is 100 into, what is mod alpha square? 1 by 5. 100 into 1 by 5, which is 20. So numerical type question, answer is 20. We got. Last part is written inside this box itself. So very nice question. Okay. Using these formulas and properties, I got the answer. Mod of z1 minus z2 whole square is mod z1 square plus mod z2 square minus 2 times real part of z1 into z2 bar. Learn that. And z0 is 1 plus I, given already in the question. So mod z0 is root 2. Mod z0 square is 2. I'll be using that. Okay. And real part of z is z plus z bar by 2. So 2 times real part of z is z plus z bar. So substitute all those things and go on simplify. Compare equations 1 and 2 and write the last part here. Okay. Mod alpha square I am getting 1 by 5. From this, mod alpha square is equal to 1 by 5. Correct. So that you can substitute 100 into 1 by 5, which is 20. Very nice question asked. Okay. First equation is satisfied for alpha. Alpha lies on the circle. Means you put z equal to alpha. Z is alpha for the first time. And 1 by alpha bar lies on the second one. So in place of z you put 1 by alpha bar. In place of z you put 1 by alpha bar for the second equation. Go on simplify. Use the properties. And z is 1 by alpha bar. Take LCM. Alpha into alpha bar is mod alpha square. Multiply the entire equation by mod alpha square and compare equations 1 and 2 will get the answer. On to the next one, question number 7. Z is given as half minus 2i such that mod z plus 1 equal to alpha into z plus beta into 1 plus I, where I is root of minus 1. Alpha and beta real numbers. Want to find alpha plus beta. So z is given. Now you can substitute here. Mod of z plus 1. Z plus 1 is how much? Z plus 1 is equal to, z is given as half minus 2i. Z is half minus 2i plus 1. Correct? 1 plus half, that is 3 by 2. Adding the real part. 3 by 2 minus 2i. That is z plus 1. Take modulus for this. Mod of z plus 1. Mod of z plus 1 is equal to root of 3 by 2 square, that is 9 by 4. Minus 2 square, that is 4. Take LCM. LCM is 4. 4 is 4 by 1. 9 into 1. 9 plus 16, 25. Root 25 is 5. Root 4 is 2. Correct? 9 plus 16, 25 by 4. Root of 25 by 4. 5 by 2 I am getting. So mod of z plus 1 is 5 by 2. Given equation. Given mod of z plus 1 is equal to alpha into z plus beta into 1 plus I. Mod of z plus 1, I am getting it as 5 by 2. Substitute z as half minus 2i. Half plus 1, 3 by 2. 3 by 2 minus 2i. Modulus you find for z plus 1. Root of real part square plus imaginary part square. 3 by 2 square, 9 by 4. Minus 2 square, 4. Taking LCM simplifying, get 5 by 2. Mod of z plus 1 is 5 by 2 is equal to alpha into z is how much? Half minus 2i. Substitute. Z is half minus 2i. Half minus 2i plus beta into 1 plus I. Correct? Beta into 1 plus I. That is, we can connect the real parts and imaginary parts here. Here, left hand side I can write this as 5 by 2 as 5 by 2 plus I into 0. Here, alpha into half. Alpha by 2 plus beta. Alpha by 2 plus beta into 1 beta. Real part. Alpha by 2 plus beta. Here I is common. I is, if you take common, what do I get? Minus 2 alpha plus beta. Minus 2 alpha plus beta. Correct? Two complex numbers are said to be equal if the real parts are equal and their imaginary parts are equal. Equating the real parts, correct? I'll get 5 by 2 is equal to alpha by 2 plus beta. Equating the real parts. Equating real parts, we get 5 by 2 is equal to alpha by 2 plus beta. Equating imaginary parts, we get minus 2 alpha plus beta equal to 0. 0 equal to minus 2 alpha plus beta. That means beta is equal to 2 alpha. From equation 1 implies, can multiply the entire equation by 2 to cancel out 2 there. 5 is equal to alpha plus 2 beta. Beta is 2 alpha, no? So alpha plus 2 into beta is 2 alpha. I get 4 alpha plus alpha, which is 5 alpha. 5 alpha equal to 5 plus alpha is equal to 1, which implies beta is equal to 2 alpha, which is 2 into 1 is equal to 2. So alpha is 1, beta is 2. Want to find alpha plus beta, which is 3. Therefore, alpha plus beta, which is equal to 1 plus 2, which is equal to 3. Very simple question asked on 29th of January, first shift, JEE Main 2024. Hope you understand. Move to the next one. Alpha and beta are the roots of this equation. X square minus x plus 2 equal to 0. With imaginary part of alpha is greater than imaginary part of beta. Want to find this expression. Since alpha and beta are the roots of the equation, x square minus x plus 2 equal to 0. Alpha and beta are the roots of this equation. I'll use the bit of quadratic equations concept also. Sum of the roots and the product of the roots. I'll be using even the concept of the quadratic equations in this problem. Sum of the roots, relationship between the roots and coefficients. Sum of the roots is minus b by. Product of the roots is c by. So alpha plus beta I can write. Sum of the roots. Alpha plus beta minus b by. Minus of minus 1. Minus b by a. Correct? Minus coefficient of x by coefficient of x square, which is equal to 1. Alpha into beta. Product of the roots. Constant term by coefficient of x square. 2 by 1, that is equal to 2. Alpha plus beta is 1. Alpha into beta is 2. I can find out alpha power 4 plus beta power 4 first. I'll find out this part. Alpha power 4 plus beta power 4. What is alpha power 4 plus beta power 4? Which could be written as alpha square plus beta square, the whole square, minus 2 times alpha square into beta square. And again alpha square plus beta square I can write it as alpha plus beta the whole square minus 2 alpha beta, this entire thing square, minus 2 times alpha beta the whole square. Alpha plus beta is 1, 1 square minus 2 into alpha beta is 2, this entire thing square, minus 2 into alpha beta is 2, 2 square. How much is this? 1 minus 4 minus 3, minus 3 square minus 2 into 2 square is 8, minus 3 square is 9, 9 minus 8 is equal to 1. So I got alpha power 4 plus beta power 4. Now my aim is to find alpha power 6 minus 5 alpha square. Also I'll be using this imaginary of alpha is greater than imaginary of beta. I'll find the actual roots of this equation. If you find the roots of this equation by using formula method, x equal to minus b plus or minus root of b square minus 4ac divided by 2a. Using that, I can write the roots as 1 plus or minus 1 minus 8 is minus 7, that is I root 7 divided by 2. Finding the actual roots of the equation. They told imaginary part of alpha is greater than imaginary part of beta. So imaginary part is either root 7 or minus root 7. Since imaginary part of alpha should be greater than imaginary part of beta, I'll take alpha equal to 1 plus I root 7, because root 7 is bigger than minus root 7, correct? So that root 7 is greater than minus root 7 satisfies. I'll take alpha as 1 plus I root 7 by 2 and beta as its conjugate 1 minus I root 7 by 2. So that imaginary part of alpha is root 7 by 2 is greater than imaginary part of beta, which is minus root 7 by 2. So that condition is satisfied. Alpha is greater than beta. Imaginary part of alpha is greater than imaginary part of beta. So alpha is this. Now I can find out alpha power 6 minus 5 alpha square. Using this value of alpha, I find out alpha square and alpha power 4. Okay. So alpha power 6 minus 5 alpha square. To find that value, you can write alpha square common from those two. Alpha square into alpha power 4 minus 5. Correct. So what I am doing is alpha power 6 minus 5 alpha square, which is equal to alpha square into alpha power 4 minus 5. Alpha square, if I note, square of this 1 plus I root 7 by 2 the whole square. 1 plus I root 7 divided by 2 whole square, is divided by 2 the whole square. And here it is going to be alpha power 4, that is 1 by 2 plus I root 7 by 2 whole to the power 4. Simplify it, you will get the answer. Use a plus b whole square here. 1 by 2 square is 1 by 4. I square is minus 1. Minus 1 into 7 by 4. That will be minus 7 by 4. 2ab part. 2 into half is 1. 1 into I root 7 by 2. That is I root 7 by 2. This much I am going to get. Here, again I should square. Square the square. Correct? 1 by 2 plus I root 7 by 2 square the square. So I'll write here 1 by 4 minus 7 by 4. This will be minus 6 by 4. Minus 6 by 4 is minus 3 by 2. This will be minus 3 by 2 plus I root 7 by 2 the whole square. Square the square. Minus 5. Correct? This part is minus 3 by 2 plus I into root 7 divided by 2. Here what you get? Use a minus b whole square formula. A square 9 by 4. I square is minus 1. Minus 1 into 7 by 4. Minus 7 by 4. Minus 2ab. 2 cancels. Minus 3I root 7 by 2 get. 2 cancels. Minus 3. Minus 3I root 7 by 2. Minus 5. So this will be simplified how much? Minus 3 by 2 plus I into root 7 by 2. Here 9 by 4 minus 7 by 4. That will be 2 by 4, half. Half minus 5, minus 9 by 2. It will be minus 9 by 2 minus 3I root 7 by 2. Correct? From the second bracket I can take minus 3 by 2 common. So what comes out is minus 3 by 2 into minus 3 by 2 plus I root 7 by 2. Because it took minus 3 by 2 out, what remains is 3 by 2 plus I root 7 by 2. This takes the form a plus b into a minus b. A plus b into a minus b. This is a square minus b square. So that will be minus 3 by 2 into a square, that is I square is minus 1, minus 1 into 7 by 4, correct? That will be minus 7 by 4 minus 3 by 2 square, that is minus 9 by 4. Using a plus b into a plus b into a minus b. A is I root 7 by 2, b is 3 by 2. A plus b into a minus b. Read like this. A plus b into a minus b. A square minus b square. Minus 7 minus 9. Minus 16 by 4. Which is minus 4. Correct? Minus 3 by 2. Which is minus 16 by 4. Which is minus 4. 2 ones are 2 twos are. 2 into 3 becomes 6. Correct? I'm getting 2 ones are 2 twos are. Minus 16 by 4 is minus 4. Becomes plus 6. Oh, I took minus 3 by 2 common. It's minus 3 common there. Sorry. Small mistake happened there. Here it's minus 3, not minus 3 by 2 outside the bracket. It's only minus 3 there. Minus 3 common. This is minus 3 common, correct? Minus 3 is common. So by 2 is kept there itself. Minus 3 is taken out from this, not minus 3 by 2. Minus 3 is taken out. So here also only minus 3 is there. Correct? This is minus 16 by 4, minus 4. Minus into minus becomes plus 12. So we got this part. Alpha power 6 minus 5 alpha square as 12. And here we got 1. 1 plus 12. Answer is 13. Required answer is 13. It's numerical type question. 13 is answer. Correct? Alpha power 4 plus beta power 4 we got 1. And it's separately. And alpha power 6 minus 5 alpha square we got 12. So this plus this is what we want to find. 12 plus 1. 12 plus 1. Answer is 13. Numerical type question asked on 29th of January, first shift, JEE Main 2024. Move on to the next one. R and theta respectively be the modulus and amplitude of the complex number. Amplitude is the principal argument. Principal argument means the value of theta should lie between minus pi and plus pi. Amplitude means the principal argument. Amplitude is nothing but the principal argument. Is the principal argument. The value of theta should lie between minus pi and plus pi. It's called as the principal argument. Value of theta should lie between minus pi and plus pi. It's called as amplitude or the principal argument. And I'm out to express this in the form of modulus amplitude form. R is modulus, theta is amplitude or the principal argument. So in the form of R and theta, I should express in the polar form. I should express this complex number in the polar form. The polar form of the complex number is this. Z equal to R into cos theta plus I sin theta. R is modulus. Polar form of the complex number. Z equal to R into cos theta plus I sin theta. Where R is the modulus and theta is the amplitude. Where R is modulus. Where R is the modulus of the complex number. Modulus. And theta is the amplitude. Okay. So I should express this in the form of polar form. R into cos theta plus I sin theta. So that I can find R and theta. So given Z is equal to 2 minus I into 2 tan 5 pi by 8. 2 tan 5 pi by 8. What I'll do is, I'll write minus tan theta as tan of pi minus theta. I'm using this. Minus tan theta is equal to tan of pi minus theta. Okay, use this. So this will be 2 plus I into 2 into tan of minus tan theta is tan pi minus theta. Tan of pi minus 5 pi by 8. Use this. Okay. I wrote minus tan 5 pi by 8. That's tan of pi minus 5 pi by 8. Pi minus 5 pi by 8 will be 3 pi by 8. Take LCM inside the bracket. 8. 8 pi minus 5 pi. 3 pi by 8. Also I can take 2 common. 2 common. I'll do in the next step. 2 plus I into 2 into. This is tan of 3 pi by 8. We can write tan as sin by cos. Correct? 2 plus I into 2 into tan you can write sin by cos. Sin 3 pi by 8 divided by cos 3 pi by 8. Take cos 3 pi by 8 as common denominator. Cos 3 pi by 8 common denominator. So I'll get 2 times cos 3 pi by 8 plus I into 2 times sine 3 pi by 8. And this cos, you take it up. 1 by cos is sec. 2 is common in the numerator. This cos will go up, becomes secant 3 pi by 8 into what we have is cos 3 pi by 8 plus I sine 3 pi by 8, which is exactly in the polar form. R into cos theta plus I sine theta. Correct? Polar form is here. R into cos theta plus I sine theta. So R is modulus cos theta plus I sine pi by 8. R into R is this. This entire thing is R. R is 2 cos 2 secant 3 pi by 8, which is found in first and second option. Third and fourth is not possible, correct? And theta is this. This is your theta, correct? Comparing with R into cos theta plus I sine theta. Cos theta plus I sine theta. Theta is 3 pi by 8. Therefore, I can conclude R is the modulus, which is 2 times secant 3 pi by 8. And theta is going to be equal to 3 pi by 8. Correct? So answer is R comma theta is option A. Question asked on 29th of January, first shift, second shift, JEE 2024. Hope it's clear. Writing in the modulus amplitude form. Okay? It's also called as polar form or modulus amplitude form. Theta is the amplitude or is also called as principal argument. Means value of theta should lie between minus pi and plus pi, including pi, excluding minus pi. Hope it's clear. Minus tan theta is tan of pi minus theta. Pi minus 5 pi by 8 is 3 pi by 8. Take 2 common, also write tan as sine by cos. Take common denominator and 1 by cos is sec. So 2 secant 3 pi by 8 into cos 3 pi by 8 plus I sine 3 pi by 8. Compare and write R and theta. Hope it's clear. R into cos theta plus I sine theta. Move on to the next one. Alpha and beta are the roots of this equation such that imaginary of alpha is greater than imaginary of beta. A, B are integers not divisible by 3. N is a natural number such that satisfying this. Want to find N plus A plus B. So find the roots of this equation by using the formula method. Okay. X squared minus root 6x plus 3 equal to 0. X squared minus root 6x plus 3 equal to 0. Solving this by using the formula method, x equal to minus b, minus of minus root 6, plus or minus root of b square minus 4ac divided by 2a is equal to how much? Root 6 plus or minus 6 minus 12 is minus 6, correct? Root of minus 6 divided by 2. Root of minus 6 is root of minus 1 into 6, which is I root 6. So root 6 I can take common. 1 plus or minus I I'll get. Divided by 2. Root 6 by 2. Root 6 by 2 I can write it as root 3 by root 2. Correct? Root 2 in root 2. 1 root 2 is cancels. I can write this as root 3 divided by root 2 into 1 plus or minus I. Root 6 is root 3 into root 2. 2 is root 2 into root 2. 1 root 2 cancels. So root 3 by root 2 into 1 plus or minus I. So we'll take imaginary of alpha is greater than imaginary of beta. So we'll take alpha as root 3 by root 2 into 1 plus I. Take alpha as root 3 divided by root 2 into 1 plus I. And beta is equal to root 3 divided by root 2 into 1 minus I. So that imaginary of alpha is how much? Root 3 by root 2. And imaginary of beta is minus root 3 by root 2. Correct? Imaginary of alpha is greater than imaginary of beta is satisfied. If you take alpha and beta like this. And you need to find this. Correct? I need to find this expression. Alpha power 99 by beta plus alpha power 98. I can use De Mornay's theorem. Also I can express this in the polar form. How to express 1 plus I in the polar form? Modulus of this is root 2 and argument is pi by 4 because it lies in first quadrant. Theta is alpha. Alpha means tan inverse of mod y by x. If you find out the polar form of this, root 3 by root 2, keep as this. Modulus of this is root 2 and the argument of this is pi by 4. So I can write e power I pi by 4. And beta is equal to, this is alpha, and beta is equal to what? In the exponential form, if you write root 3 by root 2, keep as is, modulus is root 2, and amplitude is minus pi by 4 because this is conjugate of that. So e power minus I pi by 4. Root 2 cancels here. So alpha is root 3 into e power I pi by 4. And beta is root 3 into e power minus I pi by 4. 1 plus I is a complex number lying in the first quadrant. So theta is equal to pi by 4. This is complex number in the fourth quadrant. So theta is minus pi by 4. The argument of this is pi by 4. Argument of this is minus pi by 4. Lies in the fourth quadrant. This lies in the first quadrant. Now find out alpha power 99 by beta plus alpha power 98. Alpha power 99 divided by beta plus alpha power 98. We can take alpha power 98 common. Alpha power 98 if you take common, what remains is alpha by beta plus 1. Correct? Alpha power 98 is taken out. Alpha is substitute root 3 e power I pi by 4 to the power 98 is required. Correct? So that will be root 3 to the power 98. Correct? E power I pi by 4 to the power 98. That becomes e power I into 98 pi by 4, which is 49 pi by 2. And alpha by beta. Alpha is here, beta is here. Alpha by beta is how much? Root 3 cancels. E power I pi by 4. Of course, root 3 I'll write here. Divided by root 3 into e power minus I pi by 4 plus 1. So root 3 power 98 is 3 power 49. Correct? Root 3 is 3 power half. Half into 98 is 49. Powers gets multiplied. E power I 49 pi by 2. For this, we'll subtract 48 pi by 2. And 48 pi by 2 is 24 pi. Even pi can be subtracted. So it becomes cos pi by 2 plus I sin pi by 2. Which is cos pi by 2 is 0. And sin pi by 2 is 1. 0 plus I becomes. E power I into 49 pi by 2. Here root 3 cancels. This will be e power I pi by 2. Correct? I am subtracting 48 pi by 2. Correct? No? 98 pi by 4 it was. 98 pi by 4. It was 98 pi by 4. This is 49 pi by 2. Subtracting 48 pi by 2 becomes cos pi by 2 plus I sin pi by 2. Root 3 cancels. This becomes e power I pi by 2. That is also cos pi by 2 plus I sin pi by 2 plus 1. So this will be 3 power 49 into I is I square. I square is minus 1. 1 into I is I. I'm getting like this. Now we can compare 3 power n into a plus ib. Compare this with 3 power n into a plus ib. If we compare, n is 49, correct? If we compare, n is equal to 49. Value of a is minus 1 and value of b is 1. Compare with that form, I wrote already. A is equal to minus 1 and b is equal to 1. Therefore, what we need to find is n plus a plus b. N is 49. A is minus 1. B is 1. If we simplify this, we get 49. Minus 1 plus 1 add up to 0. 49. So numerical type question asked. Answer is 49. Question asked on 29th of January, second shift, JEE Main 2024. Very nice question asked. Finding the roots of the equation by using the formula method and expressing in the polar form or exponential form, express it e power I theta, r into e power I theta. R is modulus. Modulus of this is root 2. And argument of this is pi by 4 because x is 1, y is 1. Both are positive. First quadrant, theta equal to alpha. Alpha is tan inverse of 1 by 1. Correct? And here it is conjugate. So 1 minus I is conjugate of 1 plus I. So this is e power I theta. This will be e power minus I theta. Same angle with sign change. So alpha and beta we got. Then you can substitute taking alpha power 98 common. Alpha by beta plus 1. Alpha is here. Alpha is here. Alpha by beta is root 3 cancels. E power minus I pi by 4, take it up. E power I pi by 4. E power I pi by 4, e power I pi by 4 becomes e power I pi by 2. E power I theta is cos theta plus I sin theta. You must know this. It's called as Euler's formula. E power I theta is cos theta plus I sin theta. So value of n plus a plus b is equal to 49 is the answer. Okay, please make a note of this. Move on to the next one. Z equal to x plus iy, x into y not equal to 0 satisfies this equation. Z square plus I into z bar equal to 0. Find mod z square equal to how much? Given z square plus I into z bar equal to 0. Given equation is z square plus I into z bar is equal to 0. So we can write this as z square is equal to minus I into z bar. What we'll do is we'll take modulus on both sides. Take modulus on both sides. Mod of z square is equal to mod of minus I into z bar. Mod of z square is same as mod z the whole square, because we have the property mod of z power n is equal to mod z to the power n for all n belongs to natural number. This we have. So mod z square is same as mod z the whole square, and mod of minus I is 1. This becomes mod of minus I into mod of z bar. Mod of minus I is 1. Mod of z bar is same as mod z. Correct? So from this, what I can have is mod z square minus mod z is equal to 0. From this, I can write mod z common. What remains is mod z minus 1 equal to 0. A into B is 0 means either A equal to 0 or B equal to 0. Mod z is 0 or mod z is equal to 1. Mod z equal to 1 means z equal to mod z equal to 0 means z itself should be 0. Correct? Modulus of a complex number is 0 if and only if the complex number itself is 0. Z should be 0. Z is what? X plus iy. Correct? X plus iy is equal to 0 means what? 0 plus I into 0. That means what? X is 0, y is 0, which is not possible because they told x into y is not equal to 0. X into y not equal to 0 means x is not 0, y is not 0. This is not possible. As x into y is not equal to 0. Here mod z is 1. Mod z is 1 is possible because mod z is 1 means mod z square. They asked to find mod of z square. Correct? Mod z square is 1. Mod z square is same as mod z square. Again using this property. Mod z power n is mod of z power n. So mod z square is equal to 1. This is the answer. Answer is 1. Mod z square is equal to 1. Question asked on 30th of January, first shift, JEE Main 2024. Move on to the next one. Just using the properties of modulus, we got the answer and conjugate. Z is a complex number, then the number of common roots of this equation is how much? Z is a complex number, they told. First we'll solve this cubic equation. To find the roots of the cubic equation, first we can use by method of inspection. Using method of inspection, the first root can be got. Normally, see, sum of the odd coefficients equal to sum of the even coefficients. 1 plus 2, 3, 2 plus 1, 3. Sum of the coefficients of odd powers of z is same as sum of the coefficients of even power of z. Correct? Note that z cube plus 2 into z square plus 2 into z plus 1 is equal to 0. What is given? See, z cube, coefficient of z cube is 1. 1 plus 2 is 3. 2 plus 1 is equal to 3. Note that sum of the coefficients of odd powers of z is equal to sum of the coefficients of even powers of z. That means z equal to minus 1 is going to satisfy. Sum of the coefficients of odd powers of z. Sum of the coefficients of odd powers of z is equal to sum of the coefficients of even powers of z. Sum of the coefficients of even powers of z. Even powers of z. Sum of the coefficients of odd powers of z is equal to sum of the coefficients of even powers of z, implies z equal to minus 1 is going to satisfy. Z equal to minus 1 satisfies the equation. If you want, you can substitute and say z is minus 1. Minus 1 cube is minus 1. Minus 1 plus 1, 0. Minus 1 square, 1. 1 into 2, 2 into minus 1, minus 2. Minus 2 plus 2, 0. Correct? Satisfies. Z equal to minus 1. If you put LHS becomes equal to RHS. So z equal to minus 1 is a root, means z plus 1 should be the factor. You can divide this polynomial by z plus 1. Implies z plus 1 should be the factor. Z plus 1 should be the factor. Z plus 1 should be the factor. So divide this by z plus 1. What do we get? This is z cube plus 2z square plus 2z plus 1. Z you have to multiply by z square to get this. Z into z square becomes z cube. 1 into z square. Change the sign. Minus, cancels. This is z square plus 2z plus 1. Z into z gives z square. Correct? 1 into z becomes z. Change the sign. Minus. This will cancel. 2z minus z plus 1. This z plus 1 I have to multiply by 1 to get this z plus 1. Change the sign. Remainder will be 0. Correct? Remainder is 0. That means the product of these two, this, dividend is equal to divisor into quotient plus remainder. So product of this and this will give, because remainder is 0. So I can write this as z plus 1 into z square plus z plus 1. So I can write this cubic polynomial in terms of z as z cube plus 2z square plus 2z plus 1 equal to 0. We can write this as z plus 1 into z square plus z plus 1 equal to 0. Which means what? Z equal to minus 1. Correct? Another possibility is z square plus z plus 1 equal to 0. The roots of this equation we know. It's a very familiar. Omega and omega square. Omega and omega square are the roots of the equation z square plus z plus 1 equal to 0, or x square plus x plus 1 equal to 0. It's very standard. If you want, you can use formula method and find out. Roots of x square plus x plus 1 equal to 0 are minus 1 plus I root 3 whole divided by 2, that is omega. Another one is minus 1 minus I root 3 by 2, that is omega square. So roots of the equation z square plus z plus 1 equal to 0 are omega and omega square. So this equation has three roots, minus 1, omega and omega square. So roots of this equation, the second equation, are minus 1, omega and omega square. I am finding number of common roots, whether the three roots obtained for the second equation, minus 1, omega, omega square, does it satisfy the first equation? You check. When z is minus 1, whether the first equation becomes 0 or not, to check. When z is minus 1, when z is minus 1, what we have? Z power 1985, put z equal to minus 1. Minus 1 to the power 1985. Z is minus 1. Minus 1 to the power 100 plus 1. Minus 1 to the power odd number is minus 1. Minus 1 to the power even number is plus 1. So this will be minus 1 for odd number, minus 1. Minus 1 for even number, plus 1. Plus 1. 1 plus 1. 2. 2 minus 1 is 1. 1 is not equal to 0. Z equal to minus 1 is the root of this equation, but it is not the equation, not the root of the first equation. Z equal to minus 1 does not satisfy our first equation. So it's not a root. You take Z equal to omega. Omega is other root. When you put Z equal to omega, does it satisfy? See. When Z equal to omega, does it satisfy? When Z is omega. What is my equation? Omega power 1985. Omega power 1985 plus omega power 100 plus 1. We know that omega power multiples of 3 is 1. Omega power 1985, can write it as omega power 1983 into omega square, because 1983 is a multiple of 3. 1983 if you check. 1983. How to check a number is multiple of 3 or not? Take sum of the digits. 1 plus 9, 10. 10 plus 8, 18. 18 plus 3, 21. Sum of the digits is 21. It's a multiple of 3. So 1983 is multiple of 3. 1983 is multiple of 3. Omega power multiple of 3 is 1. So I can write this as omega power 1983 into omega square, and this is omega power 99 into omega plus 1. Omega power 1983 is 1. 1 into omega square is omega square. Omega power 99 is 1. 1 into omega is omega. We know 1 plus omega square is 0. Correct? It satisfies. So z equal to omega is the root of the first equation. Similarly, I can verify that z equal to omega square is also the root of the first equation. If you take z is equal to omega square, if you take z equal to omega square, what is my equation? Omega square power 1985. Omega square to the power 1985 plus omega square to the power 100 plus 1. Does it become 0? See, omega power 1985 into 2. How much is that? 85 into 2 is 170. 1985 into 2. 1985 into 2. 5 into 2, 10. 8 2s are 16 plus 1, 17. 9 2s are 18 plus 1, 19. 3970. Correct? I'm getting 3970. 3970, I can write this 3969 into omega, correct? Omega power 3969. Omega power 3969 into omega power 1. This is omega power 200, which is omega power 198 into omega square plus 1. Omega power 3969 is 1 because 3969 is a multiple of 3. 1 into omega is omega. Omega power 198 is 1 because 198 is multiple of 3. Omega power multiple of 3 is 1. 1 into omega square. Omega square. We know 1 plus omega square is 0. So z equal to omega satisfies both the equation. Z equal to omega square satisfies both the equation. Whereas minus 1 satisfies second equation but not the first equation. So number of common roots is 2. The solutions which satisfy both the equation is common roots. So number of common roots is 2. Omega and omega square. 2 common roots for the equations given here. Move on to the next one. Question asked on 30th of January, second shift, JEE in 2024. Alpha denotes the number of solutions of this equation and beta is given like this, where z is given pi by 4 into 1 plus I power 4 into this simplified and find out. Alpha denotes the number of solutions of this equation. Given equation is mod 1 minus I power x equal to 2 power x. Same equation is found in the NCERT miscellaneous exercise of the chapter complex numbers. Given mod 1 minus I to the power x. Given mod 1 minus I to the power x is equal to 2 power x. Mod 1 minus I is root 2. Root of 1 square plus minus 1 square. Root 2 I get. Root 2 power x. This is root 2 to the power x is equal to 2 power x. Correct? Root 2 I can write 2 power half. 2 power half power x, that is 2 power x by 2. 2 power x by 2 is equal to 2 power x. Bases are same, therefore equate the powers. I'll get x by 2 is equal to x. X by 2 is equal to x means I can write x is equal to 2x on cross multiplication. So I get 2x minus x, x equal to 0. So number of solutions of this equation is only 1. Alpha denotes the number of solutions of this equation. Therefore alpha is 1. Alpha is 1 because there is only one solution for this. Beta is defined as mod z by arg of z. Mod z we can find out for this complex number. First simplify this complex number. Z is given here. Pi by 4 into 1 plus I power 4. 1 plus I power 4 is minus 4. Remember that. Because 1 plus I the whole square. You can remember this. 1 plus I the whole square is 1 plus I square plus 2I. I square is minus 1. Minus 1 plus 1 becomes 0. 0 plus 2i is 2i. 1 plus I the whole square is 2i because I square is minus 1. Minus 1 plus 1 becomes 0. 0 plus 2i is 2i. 1 plus I power 4 if you find out. 1 plus I power 4 which is 1 plus I the whole square d square. 1 plus I the whole square we got 2i the whole square which is equal to 4i square. I square is minus 1 so minus 4. So remember 1 plus I power 4 is minus 4. Even 1 minus I power 4 is minus 4. So don't forget, it's a very standard value. And terms inside the bracket I need to simplify by taking common denominator. So z is given as pi by 4 into 1 plus I power 4 is minus 4 into, here you take common denominator root pi plus I and 1 plus root pi I, taking common denominator root pi plus I into what we have 1 plus root pi I, 1 plus root pi I, correct, root pi plus I into 1 plus root pi I. So if we take common denominator we will get 1 minus root pi I into 1 plus root pi I, 1 minus root pi I into 1 plus root pi I, correct, plus root pi minus I into root pi plus I, root pi plus I into root pi minus I, root pi minus I into root pi plus I. 4 cancels. We get minus pi into, multiply this, 1 into 1 is 1, minus root pi I into 1, minus root pi I, correct, plus 1 into root pi I, that is root pi. I can use a minus b into a plus b, no? Why to multiply all the terms? A minus b into a plus b is a square minus b square, easily it cancels. Waste of time otherwise. A minus b into a plus b, a square minus b square, 1 square, 1 minus root pi square is pi into I square. And this part is root pi into root pi, again use a plus b into a minus a square minus b square. Denominator, what we have is root pi plus I into 1 plus root pi I. There I can take root pi common, otherwise multiply all the terms. I square is minus 1. What I am going to get? Here this becomes I square is minus 1. Here you multiply, open the bracket. Root pi into 1 is root pi. I into 1 is I. Root pi into root pi is pi I. And here it is I square, which is minus 1. So what I am going to get is minus pi into minus I square is plus 1 plus 1 plus 1 plus 2. Minus I square is plus 1 into pi plus pi 2 pi. Here I square is minus 1, correct, minus 1 plus root pi. What I am going to get here? Root pi plus I into 1 plus root pi I. So we can take I square is minus 1, correct? What I am getting is root pi minus 1. Here it is root pi, no? Sorry. I into 1 I. Root pi into root pi is pi I am getting. Root pi minus 1. Root pi I. Root pi into root pi is pi I square. 1 plus root pi I. What I am getting here is I is common plus I into 1 plus pi I can write. So what we get from this, it's not cancelling out. root pi plus I it was. Root pi plus I into 1 plus root pi I. Root pi plus I. Root pi into root pi is pi. Pi I into I square. I made a mistake here, sorry, just a minute. Calculation mistake is there here. This part, the last part, is equal to how much? Here, I multiplied root pi into 1 root pi, I into 1 is I, root pi into root pi is pi, pi I into I square into root pi. Correct? Now it is correct. Is equal to minus pi into, what we have? 1 minus, I square is minus 1, minus I square is plus 1, 1 plus 1 becomes 2 here. Correct? Minus I square is plus 1, plus 1 plus 1 plus 2. Here I square is minus 1, minus 1 into minus pi, plus pi, plus pi plus pi becomes 2 pi. Denominator, here I square is minus 1, this part will be minus root pi. Minus root pi plus root pi cancels. Correct? What remains is, these two will add up to 0. I is common here, I is common, so 1 plus pi. In the numerator, minus pi into, here 2 is common, so 1 plus pi remains, divided by I into 1 plus pi. Correct? 1 plus pi is going to cancel. What I am getting is minus 2 pi divided by I is equal to minus 2 pi into 1 by I. Minus 2 pi by I means minus 2 pi into 1 by I. 1 by I is minus I. So minus 2 pi into minus I, which is equal to 2 pi I. Because I square is minus 1, no? We know that I square is equal to minus 1, implies I is equal to minus 1 by I. Or 1 by I is minus I. So 1 by I is minus I. So Z simplifies to 2 pi I. Beta is given as what? Mod Z by arg of Z. Z we got 2 pi I, correct? Therefore, Z is 2 pi I implies mod Z. Mod Z is mod of 2 pi I. Mod of I is 1. 2 pi is positive. Mod I is 1. So 2 pi into 1, 2 pi. And arg of Z. We know arg of ki is pi by 2 if k is positive. 2 pi is positive. So arg of Z. Arg of Z is arg of 2 pi I. Arg of 2 pi I. Arg of ki I. Arg of ki I is pi by 2. Arg of, purely imagine the number, is either pi by 2 or minus pi by 2. Arg of 2 pi I is going to be equal to pi by 2. Arg of ki is pi by 2 if k is positive. Arg of ki minus pi by 2 if k is negative. You must know that. So arg of 2 pi, arg of this. Beta is defined as mod Z by arg of Z. Beta is defined as what? Beta is mod Z by arg of Z. Mod Z is 2 pi. Mod Z is 2 pi. And arg of Z is pi by 2. Arg of Z is pi by 2. Correct? Pi cancels. 2 goes up. 2 into 2 becomes 4. So beta is 4. Beta is 4 and alpha is 1. Alpha we got here 1. Alpha is 1. Beta is 4. Okay? Arg of ki is pi by 2 if k is positive. Arg of ki is minus pi by 2 if k is negative. All those things you must know. Want to find the distance of this point, alpha comma beta. Alpha how much? Alpha we got 1 and beta is 4. This point is alpha is 1, beta is 4. You want to find the distance, means the perpendicular distance between the point and the line. Use the formula mod of a x1 plus b y1 plus c by root of a square plus b square. Using that formula I can find out. If you want I can write one more add-on space here. Want to find distance of the point 1 comma 4 to this line, 4x minus 3y equal to 7. Want to find the distance of the point 1 comma 4. Distance of the point 1 comma 4 to the line 4x minus 3y equal to 7, correct? 4x minus 3y equal to 7, or you can write 4x minus 3y minus 7 equal to 0. The point is x1 comma y1, And the line is this: ax plus by plus c equal to 0. Distance is this formula: mod of ax1 plus by1 plus c by root of a square plus b square. A into x1 plus b into y1 plus c divided by root of a square plus b square. A is how much? 4. 4 into 1. Mod of 4 into 1. A into x1 plus b into y1 minus 3 into 4. Minus 3 into 4 plus c. C is minus 7 divided by root of a square plus b square. A is 4. 4 square 16. And b is minus 3. Minus 3 square 9. 4 into 1 4. Minus 12. Minus 7 divided by root 25 is 5. Mod of this. 4 minus 12 is minus 8. Minus 8 minus 7 minus 15. Mod of minus 15 is 15. 15 by 5 is equal to 3. Please make a note of this. Nice question asked on finding the modulus and argument of a complex number. First, simplify this complex number. B as z is equal to pi by 4 into 1 plus I power 4 into this bracket. 1 plus I power 4 is minus 4. Already shown in the steps. And simplify it. 1 minus root pi I by root pi plus I plus root pi minus I by 1 plus root pi. Go on, simplify it. Use the fact that I square equal to minus 1 and simplify. Okay. After simplifying, you substitute here. Modulus of z is 2 pi I'm getting. I'm getting the complex number z as 2 pi I. Z is 2 pi I. Mod z is 2 pi. Modulus of I is 1. So argument of z is pi by 2 because argument of ki is pi by 2 if k is positive. You must know that. If you want, I'll write here. Note. Arg of I is pi by 2. Arg means the argument. Argument of a purely imaginary number. Argument of I is pi by 2. Argument of minus I. I'll be doing the synopsis part of this in detail for both CET and JEE exams. So you can listen to that so that it becomes more beneficial. Arg of minus I is minus pi by 2. Arg of 1 is 0. And arg of minus 1 is pi. You must know this. And moreover, more generally I got this. Arg of ki is pi by 2 if k is positive. Arg of ki is pi by 2 if k is positive. And minus pi by 2 if k is negative. K is negative. And we have arg of k. Arg of k is equal to 0 if k is positive. Arg of purely positive real number is 0. Arg of purely negative real number is pi if k is negative. If you know this, you can work out. I am using arg of ki is pi by 2 if k is positive. This is used, okay, in this problem because I got the complex number as 2 pi I. 2 pi is positive number. So arg of ki, where k is positive, is pi by 2. Arg of 2 pi I is pi by 2. Arg of ki is pi by 2 if k is positive because 2 pi is positive. Alpha is number of solutions, we got 1. Beta we got 4, 1 comma 4. Find the distance of this point to the line, the perpendicular distance formula, mod of ax1 plus by1 plus c by root of a square plus b square. Question asked on 31st of January, first shift, JEE in 2024. Shown in detail, solution also, okay? I mean, the remaining part of the problem. I think this is the last question we have. 14 questions we have altogether of January shift 2024, complex numbers. Z1 and Z2 be two complex numbers such that Z1 plus Z2 is 5 and Z1 cube plus Z2 cube is given 20 plus 59. Want to find mod of Z1 power 4 plus Z2 power 4. So Z1 plus Z2 is given, Z1 cube plus Z2 cube is given. From there and find out what is Z1 into Z2. Then you can find out Z1 power 4 plus Z2 power 4, then find the mod of that. So consider Z1 plus Z2 the whole cube formula. Z1 plus Z2 the whole cube formula. The basic algebraic identity works even for complex numbers. A plus B whole cube formula I'm using. A cube plus B cube. Z1 cube plus Z2 cube plus 3Z1 Z2 into Z1 plus Z2. A plus B whole cube formula. A cube plus B cube plus 3AB into A plus B. Same thing applies for complex numbers. Z1 plus Z2 is given as 5. Correct? Z1 plus Z2 is 5. So 5 cube is equal to Z1 cube plus Z2 cube is given. Z1 cube plus Z2 cube is given as 20. This much is given. 20 plus 59. 20 plus 59. Correct? Rise root of minus 1 is understood. Plus 3 times Z1 into Z2. Z1 plus Z2 is 5. Simplify this. 5 cube is 125 is equal to 20 plus 15I. Here 3 into 5 is 15. Correct? 15 Z1 into Z2. Simplify this. 125 minus 20, that is 105. 105 minus 15I is equal to 15 Z1 Z2. You can divide the entire equation by 15. Get 7 minus I is equal to Z1 into Z2. We got Z1 Z2. Now we can, using Z1 plus Z2 and Z1 Z2, I can find Z1 square plus Z2 square. Therefore, Z1 square plus Z2 square is equal to Z1 plus Z2 the whole square minus 2 times Z1 Z2. A square plus B square. A plus B whole square minus 2AB. Z1 plus Z2 is given to be equal to 5. So 5 square minus 2 times Z1 Z2 is 7 minus I. 5 square is 25. 2 into 7, 14. Minus of minus plus. So how much? 25 minus 14, that is 11. I'm getting this as 11 plus 2I. Z1 square plus Z2 square. From this I can find Z1 power 4 plus Z2 power 4. Therefore finally Z1 power 4 plus Z2 power 4, which could be written as Z1 square plus Z2 square the whole square minus 2 times Z1 square into Z2 square. What is Z1 square plus Z2 square? 11 plus 2I. 11 plus 2I the whole square minus 2 times Z1 Z2 whole square. Z1 square Z2 square is Z1 Z2 whole square. Z1 Z2 already we have 7 minus I. So this is 7 minus I the whole square. Expand this. 121 plus 4I square plus 2 into 11, 22 into 2, 44I minus 2 into here A square plus B square minus 2AB. Correct? More calculation. Very simple question, but more work. I square is minus 1. So minus 4 there. Plus 44. This is minus 98. I square is minus 1. Minus 1 into minus 2 becomes plus 2. Plus 28I. Correct? 121 minus 4 is 117. 117 minus 96, that will be 23. Correct? Minus 98 plus 2. Minus 96. Minus 96 plus 117, that will be 21. 21. Right now. Minus 102 plus 2. Minus 102 plus 2 minus 100. So 121 minus 121. Here 44I plus 28I, that will be 72I. We can take common terms. What is common here is, if you take 3 out, 3 is out. So 7 plus 24I. I'm getting in this form. Z1 power 4 plus Z2 power 4. 3 into 7 plus 24i. Now I can find modulus of this. Therefore, finally, mod of Z1 power 4 plus Z2 power 4 is equal to mod of 3 into 7 plus 24i. 3 into 7 plus 24i. Mod of 3 is 3 only. What remains is mod of 7 plus 24i. Modulus of this complex number, in order to find root of real part square plus imaginary part square. 7 square 49, 24 square is 576, which is equal to 3 into root of 625, which is 25, 25 into 3 is 75. Answer is 75. Option B. Question asked on 31st of January, second shift, JEE Main 2024. With this, all the questions of 2024 January shift, JEE Main solve of the chapter complex numbers along with the concepts. Okay, more questions were asked from this chapter. So one of the quite interesting chapter, complex numbers. 14 questions were there altogether on questions were asked on polar form, De Moivre's theorem, cube roots of unity, modulus, conjugate, argument, all those things. So 14 questions, I'll show if you want. This was the 13th question we had like this. Sometimes I added the pages like this because not sufficient to write on one page itself. The solutions are quite lengthy. 12th one was finding the common roots, and 11th one was this finding the number of solution and then finding mod z square. Alpha, beta, this is also another question on De Moivre's theorem, exponential form I used, and this is on exponential form we had, correct? Then we had finding polar form of a complex number, and this also on use of, just to use even the relation between the sum of the roots and product of the roots with the coefficients, relation between the roots and the coefficients also used there. 7th one on this question, this solving the equation is quite simple question, equating a real and imaginary parts to get the solution. And this one beautiful question on modulus of a complex number using these formulas. Whatever formulas used also mentioned here clearly. Okay, and this is on cube roots of unity, omega properties you must know. This is on question on circumcenter, geometrical representation of a complex number. This was a question given wrong in the paper. I carried the option and given you, and also I told how to solve if the question is changed. If mod z is less than or equal to 1, how to solve, I mentioned it. This was second and first question are quite lengthy. I've taken 3 pages to solve this geometrical representation, and the first one was easy question but lengthy, more calculations were there. Like this it was. Finding the point of intersection of the circle and the straight line, and z1, z2 are 2 complex numbers satisfying these conditions. I want to find this. Okay, so all the questions, 14 questions were there. This is covered completely. Okay, complex numbers. Many more videos will be uploaded in the coming days, focusing on JEE Mains as well as NCERT as well as KCT and many other competitive exams. Please subscribe to my channel and forward to your friends. With this, I conclude. Thank you.